So let's learn about the conjugate function. So say we have a function. The mapping looks like this. So this means, say we have this mapping, and there we have an input and we have an output. So if input is Rn, output is gonna be R. So what does it mean? It means, say if our input is x equal, say x1, x2. So let's start with x1. Say if x is equal to x1, then this is basically one-dimensional vector. This is going to be one-dimensional vector. But say if x is equal to x1, x2, then x is going to be a two-dimensional. So this is x1, this is x2. So x is going to be two-dimensional plane, 2D plane basically. And say if x equal x1, x2, x3, then definitely this is going to be three-dimensional, x1, x2, x3. That's 3D. So but what if x is equal to x1 dot dot to x to the power n, xn? So that means there is n number of vectors that are acting in different reactions, and x is gonna be, the x space is gonna be n dimensional. So this is expressed as r to the power n. And here the output, on the other hand, this output is just one-dimensional because the power is basically 1. So this is a scalar. So this is what we're gonna be assuming at the very beginning. And the conjugate function is expressed like this. So f star y equal supremum of, so x domain of f, and then we have this thing y transpose x minus fx. Now this guy is basically our conjugate function. Now few important thing about conjugate function is, so fx might be concave or convex. It can be anything, doesn't matter, but f prime of y is always going to be convex. It's always going to be convex. Why? Because there are a few reasons. The first thing is, let's just write this down. Y f prime y, or the conjugate function is convex. So let's start with this, the first portion, this one. So y t x minus fx. So if x is fixed, then the first portion y of t is linear in y, and f of x is nothing but a constant because x is fixed. So that means this thing is gonna be affine. Now we know that this is our affine, this portion is affine, and then like we're taking a supremum of this. So supremum is basically whatever value we get here, the maximum of that, if that exists, and if the maximum doesn't exist, that is gonna be the lowest upper bound. So there can be a case where there is no maximum. In that case, we take the lowest upper bound, and that's why supremum is used to generalize this for all different cases. Now, this next question is why we are using this x element of domain of f. Why x has to be domain of f? Well, so let's assume x is not element of domain of f. So that means we can pick a value of x for which f of x can go to plus infinite. So if this is the case, then let's change the color as well. If this is the case, then what does our equation turns into? Like this, our so here we can see like this is gonna be plus infinite, and this is gonna be finite, right? So whatever value we have, this is gonna be kind of finite, and this is gonna be minus infinite. Now if we take supremum of this, we're not gonna get anything useful. So that's why we're taking only we're limiting the value of x to within the domain of f.